Hello, this is the Stuck in the Middle with You podcast. Welcome to all our listeners for another episode, hopefully.
Yeah. I'm Jacob Kovacs, or BAM, as I'm more commonly known.
And I am Thomas Cornish, as I am always known, and always have been known.
Always will be, hopefully.
Yeah, well, we'll see. Maybe I'm be fluid and fluid gender.
Yeah,
whatever.
That's true.
Anyway.
Nicknames can be horrible. Anywho, though, this is a heritability.
This is a heritability episode. We're here to talk about how podcasts are heritable among the population. No. So we're here to talk about heritability, environmental influences, how you kind of work it out, what they mean, because there's a lot of misrepresentation and kind of it's quite a difficult topic to understand if it hasn't been explained maybe with any clarity.
Yeah, and if you don't have the right context for certain concepts like heritability, if you don't understand how it fits in with evolution, then you can land up going completely awry with what you think it means and meant to do, for example.
Yeah. So, okay, where shall we start? Heritability. What does it mean?
That's a good place to start.
What does it mean?
Well, I think heritability it's similar to the concept of replication in some ways, because a replicator in evolution, which we discussed in our last podcast, is the act of something persisting in its existence. It's duplicating itself, and when heritability is the likelihood or possibility of something replicating itself in the next generation, to be specific to biology and evolution.
Yeah. Well, it's also, I mean, the way I think about heritability at any one time, so the heritability equation gives an estimate of the percentage of variance in any kind of trait captured within the population that is through genetic variance. So, for instance, if you measure something like a personality trait like extroversion or a trait like IQ, you measure those things and you get a load of varied scores in the population at any one time. Now, and then you want to account for, okay, is this variance accounted for by environmental influences or kind of a variance of genetic influences? So you
and the two merge together quite horribly and quite nicely at the same time. It makes things very complicated.
Yeah. Very complicated. They have to. Otherwise, there would be no point of living in an environment. So, I guess a good way to think about this is you take monozygotic twins. They share exactly the same DNA.
Yeah,
exactly the same.
Basically, clones of each other slightly.
And a good thought experiment to think about how we account for heritability and environmental influences would be put genetically identical twins into two crates. So they have exactly the same environment, right? You can put them in two crates. Now, how you can ascertain environmental influence is you feed them, so you take one crate with one genetically identical twin, and you feed them maybe some kind of diet. Mm-hmm. And you take another twin and you feed them a different kind of diet. That's the independent variable. You take them out, make them sit an IQ test or a personality trait test, and any variance within that test would be due to the environment, because of course they don't vary at all in their genetic makeup, in their genotype.
Yeah, so you've isolated the effect of whatever variable it is that you're doing. So the diet in this case, you can say, well, we know that variance is because we gave them a different diet. Everything else is the same.
So all of the variance accounted for in that population would be due to environment. That's how we work out how much environment has influenced. Now, whereas you take the other half of that thought experiment, you put two genetically
very different people. I suppose it would be best to have two people who vary only in one gene, for example. Nearly clones. That would be the best.
So you take these maybe dizygotic twins where they share half of their DNA, put them into these crates, and you completely control now for the environment. You don't make anything different in the environment. You feed them exactly the same. You feed them exactly the same time. Exactly the same molecules within their food. Exactly the same amount of protein.
Which is really important, of course.
Etc. Now you take them out. You make them sit the same personality trait questionnaire or IQ test.
IQ test is quite a good example to use. We'll probably be using that a lot.
Yeah, and any variance within those IQ tests would be accounted for by genes, because you've completely controlled for the environment. So any variance would be accounted for by their genotypes varying. So that, remember, these dizygotic twins only share half of their DNA. So it must be the reason why they differ, considering as well that they've had exactly the same environment. The reason that they differ must be due to the variance within their genotype translating into the variance accounted for in their IQ tests or personality traits or whatever it might be.
That's true. Of course, there is some difficulties that... Should I introduce things that make things it's a bit more difficult?
Really, you complicate this.
Well, okay then. I'm good at that. There's lots of random activity that happens in the body, and things can spontaneously change. Genes can end up changing without much reason for them to change. You can get mutations that happen early on in someone's life, and there's lots of spontaneous activity that happens in the brain that, in fact, I think, nearly most neuronal firing is just random stochastic firing.
But that was still random mutations. When you're talking about heritability and variances within the population, it would still count as a genetic variation without environmental influence. But when you account for environment, how we get the heritability percentage and environmental percentages, we do those dizygotic and monozygotic studies. Mm-hmm. So it's
as long as it can be accounted for. Sometimes for example, a gene that may make other genes mutate at a more likely rate. Then that can be accounted for by the genes themselves. But sometimes your population size isn't big enough to account for random mutations that happen all over the place.
It's really hard because heritability gives us a good heritability equations, and those studies we've just spoken about, they give us a good gauge of maybe what percentage would be accounted for by genes, but it doesn't give us a good gauge of what kind of things are actually genetically determined. It just gives us a gauge of, okay, this might be due to variation in genotypes, but we don't know what's accounting for those variation in genotypes.
You see, because if something affects the genotype, if something makes the genotype vary, that like the environment, then you're measuring the genes without knowing it's caused by something else. So that's where you land up with things being like the environment can be heritable, and then the environment changes someone's genes through something like epigenetics, and then you get more variability, but not because of inherited genes. Because of inherited
so it's we know a lot about, for instance, the IQ tests. They're usually around about 0.5, 0.6, like 50%, 60% are due to genetic variance within a population. But we don't know what actual genes contribute to that genetic variance at all, really. We can't really say what genetic determinism is there, if any. We know, of course, environmental influences account for about 0.5 again, or 0.4.
Roughly. The verdict may still be out on that, I think.
We're still doing studies, and we still don't really know, because we don't know how to do these studies perfectly, because there may be multiplying effects, etc. But one reason why I wanted to kind of outline these thought experiments and how we do these studies is because there's a lot of miscommunication, not intentionally, and there's a lot of confusion around about what heritability actually captures, what environmental influences actually capture. And it's just capturing how much variance within a trait in a population can be accounted for at any one time by variation in either genotype or variation within a population's environment. Right? That's all it's kind of calculating.
And it shouldn't be sort of locked into thinking of heritability as a sort of genetic phenomena. I think that's something that we're increasingly having to do with every evolutionary concept, is not think of it as, heritability is something that happens to genes. It's something that happens to anything, that's passed down.
So for instance, if I give you the question I've asked a few people this now, is you ask people, does heritability account for more of the variance in the population of having 4 fingers instead of 5, right? Like how much does genetic variance account for having 5 fingers, or how much genetic variance accounts for having 3 fingers? People will usually say, well, it's high, right? And it's like, no. Heritability, that equation accounts for next to nothing in terms of the variance within the population, because to have 4 fingers or 3 is probably due to the environment. It's probably all due to the environment. It's probably due to someone having frostbite, amputations, just kind of accidents toxins, that render your finger count. In this example, it renders your finger count down to 4 or 3. So the environment in that scenario is accounting for pretty much all of the variance in a population. Now think about that. If we think about that really closely, what we're saying, or what I'm saying is, well, we're all pretty much genetically determined to have 5 fingers.
And there was a point.
So they're different.
That wasn't the case.
So there was a point where that wasn't the case, but due to evolutionary and selective pressures, that it was the case over time. But it's like, if we think about that really closely, heritability says nothing about genetic determinism. It just says about genotypes vary, how much a genotype varies within the population, and how much that genotype varying accounts for a trait varying within that population that we measure. And I think that's more of a clarifying way to kind of think about it if you give them that 5-finger example.
Yeah, that'll help, I think. Because the default is to say, well, heritability, genetic heritability accounts for everything, doesn't it?
Yeah. So we've given the IQ example quite a lot, and Bam, I know it's one of your pet subjects, IQ intelligence. So maybe if you can tell us a bit more about IQ intelligence testing, etc. Well, so IQ sometimes it's very well defined, but there's lots of different ways in which you can measure IQ, and the different ways in which you measure IQ can manifest with different levels of heritability. People, there's lots of eminent scientists who say that IQ is very, very correlated with your genes, and if your parents have a certain IQ, then you will be determined to have a certain IQ as well. But I think, there's lots of research, and they all kind of point in a similar direction to say that, it's pretty much like 50-50 when it comes to how heritable IQ is. Is it your genes or is it your environment? And it's about an equal split down the middle, roughly. But there's also more complicating factors, like are people inheriting their environment from their parents, which then changes the way that their genes manifest and their phenotypes manifest. And there's so many different things. Your brain is meant to be plastic, it's meant to be adaptable. And with the leading theory about IQ at the moment being the efficiency of neurons, it's very easy to say that I can't see how your environment, which school you go to, how can that change the efficiency of your neurons? But it is possible. Your brain is there to be plastic. It's there to learn and change itself. And there hasn't been many studies to look at how, if we try and manipulate the environment as much as we can to increase IQ, what kind of differences can we make there? What kind of differences can we make when we're intending to change IQ? Because there's epigenetics, which can change your IQ. It can change your HPA axis a lot, and that can just for our listeners, what's the HPA
it's the
axis?
Hypothalamic pituitary adrenal axis, which is basically important to you responding to stress and your stress response. Cortisol, a really, really neurotoxic hormone that's also very important for your body to function. But it's it's not very good. And in fact, drugs that inhibit cortisol function can land up promoting neurogenesis, the generation of new brain cells, to massive degrees. Some of the best drugs we have stop cortisol from working, but of course your adrenals can go completely haywire as well. So, but I think although there's like a kind of semi-confident conclusion that's happening at the moment, where a lot of scientists are saying we can be confident on how much certain factors influence IQ, we don't know whether we can manipulate those factors and if they interact. The interaction of the environment and genes is just way beyond our understanding.
So like if we take the for instance IQ, James Flynn prominent philosopher and IQ researcher. He's predominantly a philosopher. But he discovered basically that IQ tests are renormed for the mean population to be IQ score of 100, like whenever a new IQ test comes out. So what he discovered, ever since these IQ tests have been administered, basically we had been gaining IQ points in certain facets of the test over generations. And what he discovered was we were basically getting better generation from generation. Something called the Raven's progressive matrices that is a item contained within the IQ test. And what they basically measure is abstract thinking, problem solving on the spot. So you found that practically we were getting better at this, and it couldn't just be an artifact of it's just kind of happened. It has to mean something, even though these standards were being renormed, and there's still a normal distribution along that renorming. So he discovered this kind of IQ gain, and that has to be something to do with...
How much was the gain consistent over the years?
Pretty much, yeah.
It was like 2 points, I think, every generation it went up 2 points.
Yeah, 2 or 3 points. Some countries more than others. So I think the Netherlands actually were gaining the most.
Oh, right.
Yeah.
See, I'd be interested to know if people, when they sit these exams, if they know exactly what it is that they ought to be doing or looking for. Because when I first sat an IQ test, I was like, I don't know what these shapes mean. How can I predict the next bunch of
if
shapes?
It doesn't get explained properly, the rules of the game, then you're going to have a hard time doing it, especially in the Raven's progressive matrices.
Yeah.
But
and of course that test will end up going quite old-fashioned.
Yeah, but you can control for those kind of factors of it's just people getting better at the IQ test, like basically. Well, it's like where you hit a certain point where everyone's doing more standardized tests anyway at school, like for however many years, and yet the population was still getting better and better at sitting these Raven's progressive matrices. So obviously we were getting kind of better at thinking on the spot in abstract ways. And what Flynn puts it down to is basically we were getting a lot better at thinking in the hypothetical kind of way and thinking in terms of scientific categorization. So there's a facet of the IQ test where you do associations between words, and you have to kind of abstractly kind of think about what's the association between a word.
Conceptual.
So like to give a really quite a simple one, and to give the two kind of answers and where generations differ with their kind of answers. So you say, what's the association between a cat and what's the association between a cat and a lamb or a sheep, for instance? Okay, maybe someone of a previous generation, that wasn't us, they would say, well, it has 4 legs, right? Which would be correct. And they would get the maximum points, which would be 2 points for that in a generation that was previous to us. However, our generation comes up with the kind of answer that would get 2 points a lot more often, which was, well, they're both mammals.
Okay, yeah.
So that's a scientific categorization that's more in the abstract, right? Yeah. And we've got better at those kind of things. Yeah. We've got better at those kind of things, thinking in those kind of ways. We take the hypothetical seriously. We take the scientific discipline seriously, and it's like the scientific knowledge has dissipated its way through the population, which is obviously an environmental influence.
Which is a slightly different measurement of IQ, because if you're measuring people's knowledge on things, or if it needs to use a certain language knowledge base, then you're measuring crystallized intelligence, which isn't quite something that people innately know.
So those kind of associations are still to do with a modicum of like a crystallized intelligence, but also it just goes to stratify the kind of effect environment can have on something like an IQ test, and how we think, how we categorize things, and how that allows us to think beyond the kind of concrete categorization, which is, well, of course they both have 4 legs. I've experienced them both having 4 legs, whereas now our generation would see, oh yeah, they have 4 legs, but also they're mammals.
Yeah,
like it's more of an abstract concept rather than a concrete kind of concept.
And there's some weird So if you're testing someone's knowledge about something that they need to learn, it sometimes can show to be a very good indicator of how they manage to think on the spot without any knowledge.
Yeah.
And that's like the some of the language tests which look at the meanings of words. They're very good indicators at how how well someone thinks on the spot without knowing anything for some reason.
Exactly. Yeah.
Which is very strange.
Yeah. So there had to be something to do with the environment, but over generations, the heritability equation has still been the same. It's still been relatively straight down the line, 50% to do with environmental influences and variations. And 50% to do with genotype variations, accounting for the variance.
What's interesting is trying to think of why these consistent changes in IQ happen over the generations. Is this to do with our diet? Is this to do with our society that are giving the messages about thinking in abstract terms? With more intelligent, goal-designed objects in our lives, what with technology and computers and things, are we having to think in a certain way that promotes abstract intelligence? Is this an example of the environment changing to head our intelligence, or is this an example of our genes?
Yeah. See, I would say, like, when it comes to nutrition, probably the early gains in IQ, like some of it was to do with nutrition, because we definitely got
it's the Cambrian explosion,
yeah,
as it's called, where we just our brains triple. Well, I think it's nearly doubled in size because of it's thought because of meat and calories and things.
But so like recent gains in IQ tests, they're probably like nutrition probably accounts for some of it in the early stages.
Just after the war, I think that would be very important.
We improved our nutrition. We stopped rationing. We had it was less to do with scarce resources. We had more food on offer, better food, more protein, more carbohydrates, etc., etc. More things that are good for our bodies.
Yeah.
However, it simply just can't account for all of the environmental influence and why we have made these IQ gains over time in the Raven's progressive matrices. Because actually, if you take it now, our last 3 generations have probably been eating worse than the last. Like we're more obese. What else? We're more
likely to get heart attacks. We've got more inflammation in our
coronary
brains,
heart disease,
having less antioxidants. Our brains are shutting down quicker and quicker as we age.
We're more stressed. We're more lonely.
Yeah.
Things like so. That simply can't account for why generation upon generation has been making the same kind of IQ gain in the same kind of facet of IQ test. It must be something more deep in our culture, more deep in our environments and our surroundings.
It's the Raven's progressive matrices test, which is the sort of tool that's been used to show all these changes. I think it's quite a narrow idea of intelligence. It's a very good indicator of fluid intelligence, but then again, we see differences in intelligence when using that test between men and women. We see them between races, and I think it is measuring something, but I don't think we can call that an indicator of intelligence as a whole. It's just very narrow.
It's kind of abstract reasoning with as little rule as you can possibly get.
I think it's still a certain kind of abstract reasoning.
It's basically the best test that we can possibly have without testing. Like, still tests crystallized intelligence, because you have to know what a circle is. And you have to know what a triangle is, and you have to know they're different, basically.
Yeah, I suppose.
So it's with as little rule based as you can possibly get.
Yeah.
So it's
you should try it online, by the way. It's quite an interesting test. Give it a go. See how you score.
Yeah. Tests kind of abstract reasoning, analytic ability, potential for analytic ability, and etc. etc.
Yeah. Numerical ability sometimes as well.
So what Flynn basically proposes, because throughout these IQ gains, the heritability percentages have stayed the same, like 50% to do with genotype variants, 50% to do with environmental influence, whatever they may be. And what he thinks is we've got like science is disseminated through the population a little bit more. TV shows have got a more complex, more storylines. We're better at using technology, computers. We're better at manipulating things in our environment that are to do with technology, which requires more abstract reasoning.
Yeah, our lives are becoming filled with goal-oriented objects, I think, and in order to have the understanding to just be able to go into a situation and know what to do, you know, which
we just can't think in the concrete anymore. Like it's not conducive to our surrounding environment.
We're so much more social as well. That's a massive
we've been
factor.
forced to kind of think more in the abstract and to categorize more in abstract ways. So what he thinks is, like, surely genes and variants in genes can't be accounting for, you know, this heritability equation. Like, surely there must be some kind of more environmental.
Unless the competition, the genetic competition, is really strong, and you know the importance of being intelligent. You know, maybe I suppose it would have to be women choosing intelligent men over unintelligent men again and again. I don't really see that happening much, but maybe that could be a hypothetical reason.
But it's kind of controlled because the heritability equations have stayed the same, like still 50-50. You would have seen some kind of change, right?
Yeah.
It would either be, well, if there was like severe sexual selection of just intelligence, like raw intelligent genes, whatever they may be, we have no idea. You would see all of the variants almost accounted for by just environmental variants,
because
just having crap environment.
There's loads of different potential candidate genes at the moment, so like choosing one gene still leaves loads of other genes to be varied potentially.
Yeah, I mean it's so complex. So basically, what Flynn thinks and what I think possibly is going on with this kind of these IQ gains is there's a kind of multiplier. So if you remember in our last podcast, if you listen to it, we talked about the extended phenotype, which is your genes are possibly manipulating their environments to their own ends. They kind of take these like environmental materials and they act as a part of your phenotype, like it's almost a part of your organ. So if you have take someone who has some variation in gene that makes them slightly smarter than the average, just slightly smarter, what would happen is usually they would have parents that also had these genetic variances that were rendered their phenotype to be slightly smarter or whatever. So therefore, and they would be making their environment correlate more to their genotype, fit in more to their genotype. So they may have a degree, they may have jobs that are more cognitively stimulating, and all of this surrounds the child also. So the child has these genes. The child would go through school, perhaps being slightly smarter, answering questions that are 2 or 3 marks smarter than his peers. He's getting gratified through that. That he likes it, and therefore he's kind of, okay, how can I maximize this potential? I like the feeling I get from being slightly better. It gives me some kind of status. Gets me gratified.
The environment when he comes home is there to help his intelligence grow.
So what you get here is a kind of multiplier upon the genes through the environment. So it's like a gene interacting the environment, but the environment interacting the gene, but interacting with the genes that they already have. And through that manipulation, the kid may be getting smarter and smarter. So through adolescence, so if you take an IQ test at a younger age, the heritability equation, what's accounted for by genetic variance, is actually lower. It's like 30% or 40% accounted for by genetic variance. Whereas if you measure it again, same person, in adolescence, it's more likely to be genetic variance is more likely to account for IQ score variance of like 50 or 60% now.
There's lots of weird things that happen with like child intelligence is very plastic when they're younger, and I think there's a massive opportunity there to make kids really, really intelligent by doing the right thing.
And so what must be happening is some kind of multiplier effect where the genes are actually, if they have genes that lend themselves to a more cognitively complex environment, they're going to want to sculpt their environment to surround themselves with an environment that they're more likely to succeed in, basically, is what's happening. Is probably what's happening. Now that, how well a heritability equation, like our traditional heritability equations, can account for that is up for debate, because like, how can you account for that multiplier throughout life? You would have to take an IQ test.
I think it's possible. It's just it would require so much understanding about the way, what the chances are of the environment changing a gene and the ways in which it does that.
Yeah, I mean, in ways, and the way genes may be, even potentially more fixed than we realize. That kind of multiplier. I mean, even like a multiplier could be just the way that you surround yourself with like-minded peers. You often find that you get some kind of bubble where you're around kind of people with the same sort of personality traits, the same kind of IQ, and there's studies that have been done that have shown this. Like, you surround yourselves with the same kind of people with the same kind of cognitive ability, IQ, social status, and all of these things.
I don't know if you've tried to do the opposite, where you hang around with people who are just totally different from you in every way, but it's you can tell you're not designed for it. It's really difficult.
So even those kind of things account for the multiplier. Like you grow up, you get into a kind of cognitive environment or a sporting environment that you like, and you gain friends because they're more like-minded, and so your genes are almost kind of constantly sculpting your environment, and your environment is also potentiating and accentuating the genes and your genetic potential even further. So it's really hard to separate environmental influence from genetic influence.
It's like trying to separate the yin from yang in the symbol, the yin yang symbol, because they're co-evolving. One interacts with the other, and when you have two things that interact with each other, then you land up with completely different mathematical processes, and you open yourself up to any kind of evolution that you like, because because the fact that one evolves based on the other and the other evolves based on
I suppose you like a thought experiment of this kind of genes multiplying their potential through using the environment would be a kid playing basketball. So we all know the hoop in basketball is relatively high.
Yeah, it's pretty high.
It's pretty high
for most of us.
So therefore, a child starting out just goes out to the basketball court, who's slightly more, slightly taller, and maybe slightly more athletic than his peers. He'll be slightly better. He'll score a few more 3-pointers, right, than his peers. He won't be too much better, but because of that, he's more likely to realize that he's slightly better than his peers, maybe on an unconscious level. And just because the fact he got gratification from scoring those points and being slightly better than his peers, he's more likely to go out the next day and practice a bit more. Now he's multiplying his. He's obviously got a genetic predisposition to making him taller, to being slightly more athletically, genetically gifted or whatever. Now but because he's seen that, he's been gratified. He's now multiplying that potential through environment. His genes or his predispositions sculpting his environment, whereby he's creating situations where he's more likely to be in that environment. He's practicing more.
And it's the environment offering him basketball is a sort of environmental selective process as well.
Exactly. So his environment kind of offering him that, and his genetic predispositions co-opting that a little bit more would render him. So we take the basketball experience again still. Like, he's practiced that little bit more because initially he was that little bit better. So he's practiced because he gets a lot of gratification from it. He gets social standing. He gets respected at school because he's good at basketball, this person. And so what would happen is, now he gets the best coaches because he's that slight bit better. Now, from all the way, just from this little predisposition that he had, from being slightly taller and maybe slightly more athletic, like, this could be a tiny genetic predisposition. But given that,
it could even be chance.
It's literally chance.
But maybe on his first basketball game, he may have just happened to be with people who are really bad. And
exactly. I'm amazing. So he's practiced more and more and more. He's multiplied his genetic predisposition until he gets to a kind of point where he's now a professional. Yeah. And now, if you measured his basketball IQ in air quotes or something, his basketball IQ, he'd be way ahead than most people. He's taken something that might be like a 105 or 110 basketball IQ, if you will, and he's turned it into, from co-opting his environment and from his environment kind of being there, and from his chances he will get with better coaches, because from that one initial instance, he's multiplied his environment to make his genetic predispositions work for him more. He's ended up with a basketball IQ of like 130.
Yeah, top 2% of the population.
Yeah, so it's, heritability, genetic influence, genetic variability, and environmental variability. It's all very. It's like, I hope we haven't complicated this too much, but it is a complicated subject, and you always have to take it with a grain of salt.
Yeah, and it's important to know, to learn about, what you think is restricted, what's impossible to change, and what's actually very able to change. Genes seem to be there with the idea that they are open to change and to propagate themselves.
And also, what I've heard a lot, and what is kind of confused is, say you get the kind of like, one personality trait is accounted for by 60% genetic variance and 40% environmental variance. And what people would say would be like, okay, so I'm like 60% determined and like 40% determined. It's like, no. You can only ever talk about these things in terms of a whole population. Because, of course, when we're talking about heritability, we're talking about genotype variance. What variance in genotypes account for variance seen in a kind of trait that we measure.
Yeah.
Nothing more. It can't say you may have a genotype that is very fixed to environmental influences, whereas another person may have a genotype that's not fixed at all to environmental influences. You can't say you can't take a group norm, like a population variance, and how much a genotype variance accounts for variance in the population. You can't say anything about an individual within that population, because we just wouldn't know. We wouldn't know what's genetically actually predetermined about that person, or what's environmentally influenced that person, and what we see of them today in their phenotype. Yeah,
and that's how IQ is done. You wouldn't be able to have a measure of IQ if there was only one person on the earth, or even if it was like 100 people. That's not enough to be able to
because
say,
it's completely standardized. It's completely normed, like to the population. Because otherwise, if
it's all relative, basically.
It is all relative. If you have a cohort that's had a terrible environment around you, and you've had one person that's had an incredible environment, then they're probably gonna measure better on an IQ test. And because it's normed, it's standardized to the mean equaling 100. You'd be way above the mean.
Yeah, of course.
I think that's right. I think that's right. Yeah, it would be right. Yeah,
I would think so. I mean, see, it all depends on how you're standardizing that norm and things, and that's how genes work. Like, really, it's all relative to the rest of the environment. But heritability. Do you think we are able to change how heritable certain traits are, certain personality traits? Do you think that will be expression?
So again, I mean, we don't even know what genes vary in different populations to account for like an IQ difference. All we can tell you is like, okay, we have this. What these equations are telling us is genotypes vary among people, and that variation seems to be moderately important for an IQ test.
Yeah.
Like it says nothing about individual genes. I mean, I think some studies have shown like it's going to be around like hundreds of genes that are involved in intelligence
and things. Yeah, and this sort of brings us on to the kind of theories that try to incorporate the two different sides of the coin of heritability, about genes and the environment. It's not a vice or versa kind of thing. It's not versus.
You literally can't have one without the other. You can never. The
environment made genes. That they've always been hand in hand. There's never been a point where there's been a gene without some kind of organic environment there, because the organic environment made the genes. So but there's certain theories that are trying to combine the two and say we cannot splice this hair and say, well, there's genes doing that, there's the environment doing that, and we now have the dual inheritance hypothesis, which I think is a really good attempt at trying to change the way that we see certain seemingly deterministic factors like genes, and saying, they work together. It's like one big organ, and the dual inheritance hypothesis says that you inherit the environment from your parents or if you haven't inherited the environment from your parents, maybe it's your adopted parents, but they're both working together, and we analyze the result of these two factors, and it has some really interesting theories.
So that would be shared environment. We call that in the research literature.
Yeah.
So kind of like shared environment accounts for brothers and sisters, parents that share like 50% or 25% of all DNA. So I think it's shared environment accounts for quite a lot when you're younger, but as you go to school, and your social standing and you're socialized, and your social standing in a school accounts for a lot more, and your peers account for actually a lot more in the kind of heritability environment equation.
Yes,
and things like that.
I've seen that. Which, yes, the heritability equation, which we keep mentioning, is the Fisher equation. Interesting guy. It's a really complicated equation, and it was made by someone who was not a biologist at all. He was a mathematician, but he brought together some different biological concepts, which, if you want a quick fact, was done just before he donated all of his belongings to some homeless people, and then killed himself and wrote a very bizarre will, I believe. It's a really interesting story about his life. And how he did it, but it's a really important equation, and I think it's I think there's a shortened version which is just like 4 letters long. Yeah.
I think it's supposed to be so. At the start of the podcast, we talked about monozygotic twins, which share 100% of their DNA, and dizygotic twins, which share 50% of their DNA. And I think it is you take the monozygotic twins. Those studies that you do to measure environmental influence, and then you take the dizygotic twins, those studies to account for genetic influence, and you divide them and then times by 2, and then you get the heritability. Your kind of heritability variance and then environmental variance, and how much they account for a certain trait you've just measured. Yeah. I think that's
that sounds right. It. Yeah,
I think that's pretty much it.
You can check it up and see if we're right.
And if we're wrong, you can email us on www.
You don't need your we don't need your improvements.
No, we do have an email address. It's www.sitmy .blog at gmail.com.
Wow, cool.
There it is.
I didn't know that.
Yeah, we have an email address apparently.
Wow. I'm going to spam that email.
Please do not spam us with the email address.
Please be responsible with the powers we've just given you.
Yeah, and if you would like to ask us any questions or like us to cover a topic, if you want us to maybe elaborate on a topic we've already done,
it can be as controversial as you like. By the way,
we don't care about taboos.
Yeah, I mean, my reputation is to shreds anyway, so I've really got nothing to lose.
Oh yeah,
here.
so Bam, you have a story, because Bam has just been banned on Reddit. Am I to believe twice?
Yes, twice on the feminism subreddit, which, like I said, any topics. Feminism I'm particularly learned in, or the importance and how it relates to cultural evolution. That's my whole, my whole jig.
I'm kind of a chameleon. I jump in and out of topics and try and use one to influence my thinking of the other.
Yes,
and things like that. And
that's where you get some real answers, and that's where people don't want to listen to you anymore, and you get banned on Reddit.
Yeah, and I just think everything should be up for discussion. That's how we further our understanding, right? No matter how controversial it may be and the topic may be, we have to speak about it. We have to get past our kind of squeamishness. Really, I mean, come on, we're just having fun. Like, these are they're not hurting anyone. Like, these are abstract topics we're speaking on, and we're trying to get the best understanding to influence society probably in the best kind of way. Now, don't get me wrong, I think there's definitely bad actors that are going to be going around, but sunlight is clearly the best disinfectant. And if there is people with bad ideas, The answer probably isn't to ban them from Reddit, because you can't have a discussion with them and other people can't realize how bad their ideas are.
And help them learn. If they're wrong, then they need to be taught the right answer, or the kind of logic that's the best kind, and then that's how it works.
And that's how you distinguish from a bad actor, because if they don't want to admit that they're wrong, even when they're presented with new evidence and they keep disparaging kind of views, then they're a bad actor, and it's important to identify them as a bad actor. Do you want to tell us why you got banned from Reddit?
Yes, I do. I think this would be very, very interesting.
Yeah, it'd be instructive. It'd be instructive to see the kind of toxicity that's kind of going around with taboo debates right now in our kind of sphere.
I mean, on Reddit, it is quite difficult to have a conversation with someone, and as a moderator, I can see why you might just give up and say, look, there's so many people online that are not able to learn, so I'm just going to have to shove this heap of malinformed person just on one side. But at the same time, it was research backed, so my opinion no.
Go on.
So I want to get the exact post up. That might be
commit social suicide.
Social suicide, here we go. Okay, so this isn't particularly my personal opinion. Obviously it's difficult to disagree with evidence when there is evidence, and which, like I said, there is, but my argument was it was formalized as well, and it said assumption 1 or concept 1, we are the products of our environment. We are the products of our social environment, which is governed by the opposite sex. Women are the product of the way that men have treated women, right? And men objectify women, so women are the product of an objectification of themselves. So women don't need to be funny because they're the product of not a humorous competition from women, but an object kind of competition. So basically, I was saying that women aren't funny because they don't need to be funny, because men don't look for humor in women, right? And I made that argument after reading quite a bit of research saying that every time you measure our idea of humor intelligence, which relates to intelligence, every time you do that, you find men make more funny statements that are judged by women,
Yeah, and this shouldn't be controversial.
Shouldn't be controversial. It's not my opinion for a start. It's the just findings of research.
So you were just trying to contribute on this Reddit post with observable statistics and observable research that we know from the literature to try and make the discussion flourish a bit more, to add a bit more evidence to see, okay, what are we talking about here? What the influence is, why are men funnier? Just trying to add a bit more rigor to the debate, and because I guess some people didn't like the statistics that they saw, even though it wasn't necessarily you weren't obfuscating some kind of opinion. You were just kind of, here are the facts.
Yeah, I said,
what shall we do with these?
It was a formalized argument that was trying to, explain, which I think was briefly noted in the research paper as to why this finding is the case, but it was a potential reason why these findings are the case, and it doesn't even need to be personal, because I imagine there's lots of women out there who may have disliked it because they thought, but women are funny, and I'd say, well, even if women weren't funny, you've still got so many other attributes that are more important than being funny anyway. Even when you get personal about it, it's like, I'm guessing these statistics,
and these studies, what they were saying is they weren't as funny in comparison to a kind of mean average, right?
To men.
Yeah.
It was just.
And of course, that's a it's saying something about a population variance and how they vary, right? Yeah. It's not to say that a woman can't be funny. It's not to say an individual woman can't be funny, because God knows. Yeah. My girlfriend is definitely more funny than me. You can't, again, what Bam was saying on this Reddit post was not saying we should judge all individual women and say none of them are funny. He was saying, this is what this research says about the population mean in women in humor.
Yeah, I agree.
And I think the way it gets personalized is they're just completely, whether intentionally missing the point, I don't know, to further their political goals, I don't know. But whether they're just, they're missing the point, whereas what BAM is saying with this research, it's not saying anything against the individual or anything against a individual woman. on an anecdotal
But
level.
it is
yeah?
saying, I think, you can be bold with some of the claims here. I think it wouldn't be wrong to say that if you were to take a woman and a man at random, then it is more likely that the woman will be less funny than the man, really. And there's just nothing wrong with that, It's just like, even it's a finding, and that doesn't actually change the situation.
I mean, okay, take something a little bit less controversial, like extroversion, like the way people like to seek out novelty, that kind of personality trait, and the way they like to get rewarded, and the way they like to go and put themselves in different kind of social environments. They're kind of fine with that. If you take a load of people that are rated higher on the extroversion scale, and you take one out at random, it's probably more likely that they have dipped in and out at a load of professions. And it shouldn't be controversial to say that. Like, it's just
the way
it's just the fact of science, the way it is in this very present moment. That's all it's saying.
It doesn't change anything, That doesn't mean to say that the situation is any different. You're just learning more about the situation as well. And I think the arguments get really interesting because if someone takes something personally and you're saying, no, but it's just a scientific fact, and they're saying, but I'm making this scientific fact a personal deal, and then that's when the debates and arguments get very interesting as well, because the sort of personal attribution or offense that they take to that is still a scientific statement as well. And I think you can apply the science to someone's subjective, emotional quibbles that they may have. And that's, I think, when you can get really, you can pin things down, you can pin people's opinion down to being right or wrong. And that's what I really enjoy about, the feminism subreddit.
I mean, it does get dangerous when you get to more prominent people. Like, I think it was Sam Harris, basically because he had Charles Murray on his podcast, and Charles Murray researched intelligence, and in his book The Bell Curve, for instance, he had this one chapter on different IQ means in different populations, and different populations obviously means different kind of races within those populations, or ethnic minorities or whatever. And he just discovered that they differed in their mean IQ scores. In
some cases, quite a lot.
Yeah, but what happened to Sam is he had Charles Murray on his podcast, and the usual suspects with Sam: Glenn Greenwald, Reza Aslan, bad actors, who share they share videos of things that he said, like these chopped up videos to make Sam Harris out like a racist, which he is completely not. And Ezra Klein, basically one of the editors of Vox, commissioned an article that didn't quite give the most gracious explanation of his views. I wouldn't go as far as to say it was bad faith. I don't think Ezra acted in bad faith. I genuinely think he had a disagreement about the kind of science and how much environmental influences and influences IQs in different races, and etc. etc. But it got a little bit nasty, and
it got a bit out of hand. I think it's we need to be skeptical about the opinions that we quickly make concerning race or IQ and things like that.
And how personal these beliefs are actually held, and what they're actually they're actually trying to get across. Like, just because you talk about IQ differences within different populations and how they differ in different populations to different populations, says nothing about someone's actual held politics or social opinions or whatnot.
And it's there to help people, If we find something that's really controversial, then what it says to me is...
Well, science can't be controversial. By definition, science cannot be controversial.
I think people can make things controversial.
They make things controversial.
And then it becomes... the controversy, then that sort of becomes controversial as well at the same time. But it's an opportunity to help people, And I say, if there is a difference that people don't like the existence of, but it exists nonetheless, then...
Well, let's try and find the science that changes that. Yeah. If it's not conducive for the society we want to build, then, okay, it's important that we know there's differences, and therefore it's important that we do the follow-up research to see what influences those differences and how we can manipulate it, and how we can change our environment, schooling, education, adoption, parenting, to make those environments so
we can improve ourselves.
Yeah, so the individual can achieve more. Like it hasn't changed my political opinions, where I just want to see every single individual make the most out of their, whether it's genetic endowments as they possibly can.
Yeah.
Basically, it doesn't change any of that.
Yeah.
The science does not change any of that.
Yeah, it wouldn't, but you kind of need to have it. It's not very widely accepted sometimes, those opinions about having a robust enough preface to using science and thinking my principles to use science are to, help everyone better themselves. Some people don't have that. They think science is a way to find out who's better than others instead of science is a way to better everyone. Yeah. That's the worry, really. And you'd be surprised who might think that without knowing it.
Yeah. So, on that note,
indeed. Don't use feminism, the subreddit on Reddit, because the moderators are very quick to judge.
And they will exclude you if you offer evidence.
Yeah, right.
How crazy. They exclude you for offering any kind of research-backed evidence. Just putting it even on a Reddit, and you get banned.
Research is quite rare.
So, therefore, there we have it. I hope you've enjoyed this kind of talk about heritability, environmental influence, and how environment can kind of influence genes, and how genes influences the environment and kind of manipulates it. And our little talk at the end about basically political correctness, I guess, and taboo topics, and
the use of science and the importance of taking things objectively.
But yeah, I hope you have enjoyed this podcast. Please tune in again, hopefully sometime next week for our next one. And have a good day, have a good week. Feel free to email, feel free to comment any suggestions of things we should talk about and how we can improve this podcast.
Indeed. Any topics, controversial or not, please let us know what you want to hear.
We'll give you evidence-backed kind of opinions and informed discussion, hopefully. But anyway, thank you. This has been Stuck in the Middle with you. And
thank you. Stay educated. Keep calm and carry on.
Very British. Anyway, thank you very much and goodbye.